This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seeberg. Robert, good morning. Back from your pilgrimage to Silicon Valley.
Yes, good morning. Yes, I was at the GTC and I'm now very happy to share some impressions.
Oh yeah, very much looking forward to. I had almost expected you to be late because I assume you're still kind of living in the other time zone. No, you're perfectly on time.
Yeah. Okay. So what do you want to hear? What do you want to learn?
Well,
you are a Silicon Valley professional, yeah?
I would have loved to be there. For me, it's quite some time back. It's probably 20 years. So probably the first time I went there is probably 30 years back. But we're not going to make this too big because this is about you. And so when we talked, while you were there once or twice, it's so nice. But you tell us, what was your experience? Why did you go there, and what was your experience?
So there was a little tech show called GTC by NVIDIA.
Right.
But it's unbelievable. Roads are closed in San Jose. Restaurants are super crowded. Uber rides cost 3 times as much as on a normal weekdays. And you meet celebrities on every corner. We met Pat Gelsinger. We met Michael Dell, Michael Bronstein, Zach Lipton, and many more. It was unbelievable.
And when you say who did you go there with?
I went with Sepp and Albert from NXAI. So we were invited by the guys. And yeah, it was very impressive. The keynote, 20,000 people in the stadium. That's unbelievable from a European perspective when it comes to tech shows or something like that. Yeah.
Okay. Yeah. As I said, you kind of brought me back to Silicon Valley, and I don't know how it is today. I think things have changed. I was sharing with my wife last night, I believe, but that was more about politics. We're not talking politics, but I do recall that I was at 4th floor RMB, Robert Noyce building, Intel, where this line of huge black cars was coming in. And that was at that time going for the Democrats to be president. We never talked politics. That was a typical thing, but that's what I recall. I think that's changed in the Valley. You did pass the 101, I believe. You visiting one specific company that still exists. It must be even more crowded today, I guess, than it was at that time.
I was a little bit surprised because the essence of the conference are tech talks, but you are mainly there to have meetings with NVIDIA or AWS or Dell or one of the others. So NVIDIA has rented offices all over around the city for this. And then you go from meeting to meeting to meeting. And it's not all about the tech talks, right? So there are customer tech talks by NVIDIA, but the main focus is going from meeting to meeting to meeting to meeting. Yeah.
Yeah, really. So it's like what we call a house exhibition.
Yeah.
Kind of, right? It's so one company
compared to our machine building companies. Yeah.
Yeah, they do the same thing, right? And not always as big as this, I guess.
No, not so big as NVIDIA does. But yeah, I was surprised that meeting, rent whole offices only for these meetings. Impressive. Yeah.
What, nevertheless, were your main takeaways from Jensen's? Maybe to start with that one. I mean, I did see a part. How long was it? Was it 2.5 hours? Something?
2 hours. Yeah, that was.
Was it 2 hours? Yeah, right. He keeps on talking, right? So, what were your main takeaways from what he was saying this time?
It's all about inference, and more inference. So
what? Inference. Oh, yeah,
inference.
Right. Inference. Edge, I guess.
No, well. Yeah. But the industry is not letting go of this topic because it determines loss or profit, right? So inference is the whole thing. Yeah? You can counter this with hardware or with new architectures, but inference is the huge topic. Everybody talks about inference when it comes to agents. That's the huge thing to make money out of it.
Sure. Well, it's not a. Well, we've been saying this for many, many years, of
Yes.
course, right? So great to hear that
Jensen always
of course,
already
he needs to jump. But we've always said, like, many years ago, at that time, it was 2080, 20, or less than 20 edge inference, and but it's because of the evolution, right? We first needed to build, we still need, but we come to a point where maybe we don't need the huge foundation models anymore. I don't know, that's a different topic. And now we have so many of these, we can do so many amazing things, and where we do them is close to where people, or at least where machines, right, where machines are. So that's inference. That's what we've been saying. That's why it will turn around to 80-20. And probably, if I hear you correctly, they're probably maybe not saying 80-20, maybe 99-1. I don't know.
Mm-hmm. And the second big topic is tokenize the world. That's the NVIDIA credo, I would say. Tokenize everything. Everything will become tokens everywhere. Everything will be tokenized. And what I found interesting is that the companies should also set up an AI factory in which, of course, NVIDIA hardware converts their world, so their production lines, their products, into token. And this means then at the end, Arbor, Trumpf, Vitron, and all the others are now to build digital twins and cast their applications then also in tokens. And that's the new big thing, to tokenize everything. That's sure, it's very good for the NVIDIA business, but yeah, of course, because you can buy the whole data infrastructure NVIDIA together with Schneider Electric. You can buy everything at NVIDIA. Yeah.
Yeah. Oh, you mentioned Schneider. Yeah, because I announced we were going to have a podcast with them. It was sad they had to cancel. Nevertheless, I did see their logo, but then again, all the other logos as well, of all the engineering, all the other companies in industry, and everybody is so what should I say? So positive, so proud. On LinkedIn, when they see their logo, when Jensen steps away on the big screen, and then you see all the things happening. Now, how is he thinking then of these? Does he call them AI factories? I believe so.
AI factories, yep.
Let's say we have a factory. So we're building a new factory somewhere. We're going to produce whatever, let's say batteries. Does that mean that somewhere, as a part of that big factory, there's going to be, let's say, a room, and in that room there's going to be whatever,
a lot of NVIDIA stuff?
Right. Yeah, I assume so. But is that then going to be the start? And me looking further again, at some point in time, does the tokenization take place again on the edge or not?
No, this is not an edge business.
Right. Yeah, he doesn't want it to be edge yet. No.
He doesn't want it to.
Sometime it's going to be. I do have a question, or at least a thing that we can talk about, because another guy, I'm not sure if you met him as well, Jan LeCon, or if you saw Jan, he was there as well, right?
Yeah, he was there.
And he says, quote unquote, I'm not interested anymore in LLMs. We know that, right? We've heard that many times, but specifically he says,
yeah,
they are just token generators, and those are limited because tokens are in discrete space. I'm more interested in next generation model architectures, et cetera, et cetera. We know that's not the point, but interestingly that he was giving.
He's not interested in tokens.
Was that I think I saw a picture. I don't know who he was talking to. Was he talking to Jensen? Somebody else maybe? I don't know.
No, yes, I think they had a discussion, but I was in a meeting,
Oh, yeah. I think there was not sure moderated, but there were two people talking. I don't know. That doesn't matter. So at least he was. But then Jan has always had this perspective that, and many other people do as well. Some people are saying, we're going to be close to AGI, LLMs is enough, we're already in there, whatever. And Jan is typically representing, no, this can never happen. This is not possible with LLMs. He says 4 things: understanding the physical world, having persistent memory, and ultimately more capable of planning and reasoning. So we're going to continue to follow that.
And I was surprised because industrial AI and robotics are still important topics there, but there's even more going on from my point of view when it comes to the medical sector. That was my impression. And my conversation revolved around proteins, drug discovery, etc. There's a huge topic there in Silicon Valley medical sector. And not surprisingly, a lot of people talked about AI for supply chain and how to manage the supply chain with new political ideas, tariffs, and etc. etc. So this was a huge topic, AI for supply chain planning. That was
supply chain as part of logistics, or logistics part of
logistics, yeah.
supply
How to
chain?
manage that, yeah.
Okay, well,
And sure, robotics was a topic, industrial AI, but I think there's a lot going on in the medical sector, proteins, drug discovery. That was, yeah.
sure. Well, that's very similar to what CUSP is doing, right? So CUSP is doing it for material. So it's really inventing.
Inventing, yeah.
I think it's inventing new materials, and you and I not being in the medical space, but I just do assume that the idea is the same. And I think we discussed it before. You're looking for a new protein, and I believe what they do is they try to do something, build a team of medical people, and it takes years. And at the end of those years, oh, it's so sad, it was the wrong thing. And now they can do that kind of within, I don't know, weeks, days, hours. They have so many different options, and I believe AI is helping them to go for one potential protein, which then at a very, very quicker time tells them. And I think it's the same with the material. Yeah.
Yeah, and there's a lot of money for that, yeah, in the Silicon Valley when it comes to medical and drug discovery and proteins and genes and stuff like that. And we met some guys, and he said, "Oh, you're running at a startup in the industrial AI sector. How much money do you raise?" We raise billions of dollars because we are in this medical sector, and everybody is. But I think maybe it's also because they have not so much mid-size industrial AI companies over there.
Sure. Well, that's a huge difference, specifically relation to Germany, maybe also the other industrial countries in Europe. Same for Italy, France, Spain, and the other ones. Yeah, we typically have these hidden champions, right? Which you and I know. You know them at least more than I do. And if you're not in that space, you have never heard of them, but they do typically make a couple of billions a year. And they are typically number one or two in their specific market globally, right?
Exactly. And then there was a lot of hardware for sure. Jensen announced a lot of new GPUs, new clusters, new racks, etc., etc. But the focus was on Google, AWS, Azure, and Dell's, all of them. Not so much the industrial software application simulation stuff. And then there was something very interesting, and this was I would call it hardware highlight. It's called DGX Spark. And DGX Spark is as big as an edge device, and the user can work on the move. So it offers 1000 AI TOPS in an energy efficient compact form factor. And with the pre-installed NVIDIA AI software package, 128 gigabytes of memories, and you can fine-tune and you can work with the latest AI models with up to 200 billion parameters locally, and that's the way it will go. NVIDIA has the edge firmly, and they want to go on the edge, and I think we will see more of them when it comes to edge devices.
That sounds like an edge. It sounds like I just take my smartphone on top of it, and that's going to be my new smartphone. Right? How big is it? How heavy is it?
It's big as an external memory.
Oh, right.
When you add an external memory to your laptop, or maybe an iPad, maybe like an iPad, yeah.
Oh, there you go. So at least for those of you that were, well, most of you listeners probably were not. But then when did Nokia start? First mobile telephones. Some of you have maybe seen them in museums because I have experienced them directly myself in cars. You could take them out. They would be like, 5 kilos, something like that. So that's Sure, and if that's what they're doing, then that's going to be sure. We know it's all going to be inside of our what I call smartphone today, right? AI phone, the great term that Deutsche Telekom is using for it, I believe.
There were a lot of German companies. Schaeffler was there, Schunk was there. Then some European companies like Universal Robots and Agile Robots. So a lot of robot companies from Europe. And when you talk now to these robots experts, and they were typically skeptical as to whether it always have to be NVIDIA hardware next to the robot in the future. So they see that there is maybe I would call it a risk only to rely on NVIDIA hardware. I'm not sure, but yeah, they are talking about what can we do to be faster at inference without building GPUs next to the robot. Yeah, that was a huge topic at the conference also.
Oh, okay. Yeah.
And I've never visited a tech conference in Silicon Valley where Apple was not a topic. Nobody talked about Apple.
Well,
nobody talked about Apple there.
Nobody dares to. Well, I mean, there have been changes. So they're changing at least the management responsibility for AI, right? I don't know if you saw that one. Yeah. Yeah, there was this person on LinkedIn. He was making a weird story that, that it was like they knew exactly what they were doing and they were just not bringing it out. Yeah, it's a lot of BS, really. What should I say? Yeah, and then a day later, I saw that the responsible person for AI is going to be somebody else. Yeah.
Yeah.
Okay.
And I have one side note. I have to mention this side note because it was so impressive, because then we had a break for lunch break, and then we grabbed some food at a food truck, some Mexican stuff. And then we went to 3-4 chairs, and there was a guy sitting from Google, and then he recognized, oh, it's Zep. And then he came to him and said, oh, you can have a seat here. Please sit. I'm a big fan of you, Zep. Thank you for making this all possible, because without you, this whole conference won't be able to run, because you were one of the pioneers on when it comes to deep learning, and everything was invented by you guys. Thank you very much for that. And it was so impressive to see that he's a big star over there.
Oh, that's great. Was he walking around in his red pullover, recognizable?
Exactly.
So like Jensen in his black leather, Zap his brand is his red pullover, right?
Yeah, exactly.
So whenever you see a guy walking around in a red pullover, you shout Zap, and if he turns around, it's
yeah, exactly. It was so impressive that they came to and say, thank you that we're being, and I've never seen that at European conference or stuff like that. Yeah.
Oh, amazing. Yeah. Amazing. Do we have time for 2-3 topics or?
Yep, sure.
I have one, vibe coding. Everybody talking vibe coding. So it's a term coined by Andrei Karpathy. It's what I believe, because I think he wrote it on X. There's a new kind of coding, he says, I'll call vibe coding, where you fully give into the vibes. That's where it comes from. Embrace exponentials. Forget that the code even exists. Hundreds of posts. Most are about in 1 week, really. Most are from coders, say they want to start a business repairing the inefficient code. So they really question, the use of the AI tools. Then there was Stefan Langer. He's an AI engineer developer. He spotted a vibe coder job posting. I'm going to share some pieces of it. It says we're a hunt for a vibe coder, a developer who doesn't just write code, but orchestrates it through the power of AI. You'll use tools like Cursor, Bolt, and Windsurf to leverage or API. This isn't about grinding through syntax. It's about prompting, iterating, and vibing your way, the same term, to a brilliant front-end product. So I'm not going to go further details. So that's happening already. So companies are already looking for these people at the same time. And there was a guy, name is Toby Rogers, head of product at Hedgehog Lab. And he says, he's one of the examples of what I've been talking about. He says, AI is changing the game for me. I'm a PM, I guess, product marketer, manager, who never properly learned to code beyond hacking together games in Sinclair Basic. That's what I started with, basic, many, many years ago, and hand coding my first block in HTML. That was enough to get by, but building real products, that always felt out of reach. Not anymore, is what he says. He says, I recently spun out working proof of a concept in 45 minutes using ChatGPT, Bold, Supabase, and something else. No bottlenecks, just an idea. And there he goes. Scary, yeah, little exciting, absolutely. We're all riding this wave. Question is, how do we steer? That was one of two, I would say, supporting ones of this vibe coding. I must say the majority of a very big 80-90% is very negative. My feeling, I must say, and I'm going to share my view here, I've shared it many, many times. I do believe that, and I call it I started many, many years ago I wasn't like a coder, but I did code. We started it. Now let's eat our own dog food, basically. Now, I really believe so. And I strongly agree with Jensen, to come back to Jensen just once more, who said a couple of months back already, right? AI will do the job for you. So kids don't need to learn. I've always said that is not necessary. It's very good that young people and older people, that they learn about what's happening in our world of automation, digital, what is AI and how does it move and how does programming, coding work? That's, as an introduction, that is, I think, very good for many, many people to learn. Now, and at the same time, of course, I must say, again, disagree with Andrew Ng. I start disagreeing with Andrew more and more these days, I realize. But there you go. I'm still very happy with having learned basic introduction of machine learning from Andrew 10 years ago, because he says, people discouraging others from learning programming on the grounds that AI will automate it. He sees as the worst career advice ever given. And I think it's exactly the other way around. I really believe that we have to be honest. And when people say, I'm going to, learn coding for the next 4 years, they must know what is the status of which is we're in today, and not just jump into it. That's what I strongly believe.
Yeah. What else do you have, Peter?
I've only one more, I believe.
Yep.
MCP, Model Context Protocol. We did talk about it, Anthropic, right? But maybe we should talk about it again. That was the big, we talked about a couple of months back, but it's the other big thing now suddenly almost exploding. And then I was, of course, interested in, and I said, how about an MCP for connecting to industrial sensor or PLC machine data? And I'm going to share 2-3 lines from Armin Hatzalic from Siemens. We talked about industrial agents a couple of months back. So he says, imagine the shop floor. OPC UA is your data layer. Machines constantly sending real-time data like temperature, error information, keeping you informed. MCP, on the other hand, acts like a smart assistant that not only gathers that machine data, and I believe in the end, it can potentially, that's my point, gather then the OPC, the detailed data, if that's what you need. But he says, plus extra info like maintenance history, operating hours, etc., etc. I'm going to jump here to the end. He says, in short, if you need rock solid real-time machine communication, OPC UA is still the go-to. But for AI-driven insights and smart coordination across diverse data, MCP is really opening new doors. And he's just representing, which I'm sure all of you, dear listeners, are doing in case of these new technologies. We're closely watching, is what he says, both the engineering operation sides to see how MCP evolves in the industrial environment. That's, of course, what you and I will do as well.
That's interesting. Yeah, Stefan needs also to look at that, I think.
Most certainly. Yeah, it is. Maybe one final close comment from another guy. He's called Mo Tenabian. He's the CEO of Generative AI Stealth Co. I don't know yet what it's going to be. He has a big claim. That's what I told him. He says the big lie in enterprise and industrial AI: fix your data first. He says if you've been told you need to spend years cleaning your data before AI can work in your industrial operations, you've been told a lie. That's a bold claim. That's what.
That's a big.
But I'm sharing it nevertheless. if he's going to come out with proof in the next couple of months. And that's what I suggested to you already, right, Mo? If you're listening, then we're very happy to talk to you. He says it again. No, I'm not going to, Mo, but that's what I said. Brave claim. Can you support? Because I've been saying, fix your data first. That's where I'm completely with Andrew Wang still, and with many, many people. And because I've been saying, OpenCUA makes your AI fly, and that has most certainly been the case until today. Now, if it is so that Gen AI is going to fulfill the promise that we started with almost like 10 years ago. 10 years ago, there were so many companies saying, oh, just give me all your data. It doesn't matter. Just give it and we'll make it work. That never, ever worked, that promise. Now, if now Mo says, but this time it is working because of whatever, I don't know, then we're very happy to talk to you, Mo, and share it with our listeners.
Perfect. I forgot something, Peter. I'm supposed to give you Jakub Tomczak's best regards. We met Jakub in San Francisco. He's now working with the Zuckerberg Foundation. And he promised me he will be coming to our event in October.
Oh, that's great.
And will hold one workshop on Gen AI systems. So I was very happy to meet Jakub in San Francisco.
Very much looking forward to, Jakub, because we miss you already this time, and it's so nice to hear that you're going to be there the next time.
Perfect, Peter. What do you have in the main part?
I talked to Jay Lee.
Oh, who is Jay Lee?
Jay is a Clark Distinguished Chair Professor, Director of the Industrial Artificial Intelligence Center, University of Maryland. Why did I talk to him? Jay and I talk about industrial AI. Well, that's nothing new. That's what we always talk about. But there was something very specific because we talk about the present, the future, but also the past. That was the reason we talked, because he was he, question mark, the first one, at least in two official papers to coin the term industrial AI. But maybe, and I'm not going to lift the share here, maybe there was even somebody else or another company that even before him was using.
Oh, kudos to Boris.
Yeah, right. We always thought it was you, Boris Scharinger from Siemens. I do believe that Jay was there before Boris. I do not at the moment have the dates. If you want to know, listen in. And then you're also going to hear from Jay that maybe even there was somebody else who actually before him coined the term industrial AI.
I'm really looking forward. Peter, see you next week at the Hannover Messe. I'm really looking forward to meet you in Hannover. I'm looking forward to our discussions on Thursday. And yeah, I'm looking forward to the main part.
Great to have you back, Robert.
Thank you.
Thank you, dear listeners. Having you soon with us again. And Robert, have a good day. See you next week.
Bye-bye.
Bye-bye. Today I'm going to be talking to Jay Lee. He's a Clark Distinguished Chair Professor and Director of the Industrial Artificial Intelligence Center at the University of Maryland. And Jay and I are going to be talking about, well, what else? What I assume to be one of, if not the common interest between Jay and myself, industrial AI, past, present, and future. Hello, Jay.
Hi, Peter. How are you? Thank you for the opportunity.
I'm fine. Thank you very much. Why don't we start with you introducing yourself to our listeners, Jay?
As you said, I'm currently leading this industrial AI center at the University of Maryland, College Park. So previously, I also was founding director of Industrial Intelligent Maintenance System Center, or called IMS. Work with over 100 some companies globally at the University of Cincinnati. And of course, I also serve as a vice chairman of FOSCON and during the 2019, 2021. And previously, I worked with different type of industry, like automotive industries and aerospace industry, as well as work for National Science Foundation, U.S. government.
Thank you. As I shared, I think a couple of weeks back in our news section, I had asked ChatGPT who first used the term industrial AI. The reason for that was that, sometimes on a Sunday, I look at the number of people that do have this term, in their profile, and it's growing at a huge speed. So it took about a minute to search, and then it came out with you, quote unquote. The term industrial AI was introduced by Professor Jay Lee and his colleagues. They define it as a systematic discipline which focuses on developing, validating, and deploying various machine learning algorithms for industrial applications with sustainable performance. End of the quote. And then there's a link to the ResearchGate.net title, Industrial AI Predictive Analytics for Smart Manufacturing Systems. We're going to put a link into the show notes for those of you listeners who want to go and have a look yourself. And that's from June 17, 2020. That's actually roughly the time when Robert, who's my co-producer, and we published a book on industrial AI, but we did it in German. So it's a great honor to be here, to have you here with us, Jay. Also, I then asked ChatGPT for media resources like websites, podcasts, and up it came exactly with us, the Industrial AI podcast. I'm not going to give that quote. Just believe me for it. Yeah, we had actually started 2019, but again, in German language, and we changed, I believe, in August of 2022. So I'm not sure you're going to tell us. I'm going to tell us if that is actually correct, because as I started now with the past of industrial AI, I started reading into exactly this paper, and there was a reference, and I believe, and you can please comment on that you already coined the term industrial AI in 2018. Is that correct?
Well, yes, partially correct. The reason is, I think that more or less, if you if you look back 10 years, 20 years, right? So people more or less use some kind of term, but for example, my former postdoc joined the GE Global Research in 2007. His group was called Industrial AI at GE Global Research. So GE has been using the term for back and then. But the problem is that any term you can use it. But 2016, actually, we held the first Industrial AI workshop, actually, in Cincinnati, Ohio, because our former center, Intelligent Maintenance System, had a major transformation strategy to move away just from a predictive maintenance, trying to look at the future, how to predict all the future complex industrial systems, including semiconductor. So 2018 was a time, and IBM Watson host our first industrial AI official industrial meeting. That was at IBM Watson in Yorktown Heights, New York. So IBM offered say, hey, Jay, we like to host your industrial AI workshop to kick off. That's a new endeavor you're trying to do. That's exactly official. So we had many over 100 companies came, including NVIDIA was there. So that was the starting point. And 2020, of course, we published a book called Industrial AI and by Springer. But that was during the time I served as a vice chairman and the board member of Foxconn Technology Group.
I saw those pieces of information on your website as well. Again, for listeners who want to go there, IBM Watson, GE. Yes, I was following them. I think they were at the very, very forefront of the things actually taking place today. NVIDIA, they were not as big as they were today. There you go. Before we get into more, maybe technical details, maybe you want to share with us what was kind of the environment that you had been working in up until, kind of, you didn't say maybe coming up with, but dealing with the concept of industrial AI. What was before industrial AI, so to say?
Let's look at, because you suggest the topic of past, the present, and future, right? So if you look at the past, during 1980s, really was a time that major automation took off, right? That's during the 1980s. But whatever we say, but during the 1970 oil crisis and the 1980s, then NC and everything introduced, and then the computers. But the 1980s really for manufacturing industry, that's what took off, right? Robotics, major growth from there. But what happened is 1990s was a time, actually, if you take a look at it, there were a lot of e-commerce activity and until bubble late 1990s. Everyone remembers that's what it is, right? So for industry, people start talking a term, a big data. That's very challenging during the time. So we start that year 2000 say, well, we want to build this industrial, a big data, right? So how we take the data, we can predict potential failure, like jet engines and wind turbines and semiconductor equipment. So that was like a focus on the maintenance during the 2000. At that time, most of the phone could not connect to internet. Majority of phone could not connect to internet, right? So eventually, where's your edge devices? There's no edge devices. But that's where the early stage we can develop a called the predictive system on machine in a controller, like a PLC and the industrial PC, and we call edge devices at that time, like Komatsu bulldozers. We predicted that a potential failure during the work in the field. In the Cincinnati had the aviation data centers that collect all the engine data. Our researcher was working there to look at what potential. Then you have a Procter and Gamble in Cincinnati that trying to monitor productivity using a data generated from the machine to predict the downtime. And Toyota, Georgetown, Kentucky, a Camry factory was working with us. Hey, how do you predict the factory machinery to achieve zero downtime? Eventually, we call the worry-free production, right? So those are the period. So we did a try and error, and we did a progressive lesson, and sometimes we fail, sometimes we learn. But until, if you look at the whole thing people have done, right? Many pieces until German talk about Industry 4.0,
Oh, there
2011.
you go. It's written down here. Yeah, exactly.
Exactly. So that where people start thinking, hey, that's a wake up call. People say, hey, even Germany is rethinking how to make things better and more valuable for not just being a smart machine. But so during the 10 years from 2011 to 2020, you can see that a lot of people start thinking is industrial internet, data, right? Start thinking, what can we do with the data? That's where start paving the foundation of a lot of early thinking. Hey, we need to focus on more data-centric system, not just a network-centric system. Big data is going to be the value for an insight for predictive system. That's where people start focusing on, right? How can we use more integrated approach and machine learning, model-based and physics informed in a neural network approach. And so that's the actually most thing happened for the last 10 years, right? And when ChatGPT happened, and then people said, wow, this is another inspiration. Wait a minute. It's not just about our industrial system. Now we have a lot of social network, a lot of text images out there. Nobody can see it, but somebody made a major effort. Hey, we can use those open source, open data to generate a kind of like a generative machine learning. Eventually can give you a smart content generation. That's where inspired a lot of people today until most recent, right? And you have a deep seek. Wow, you can use distillation and to generate multiple model or a mixture of experts. And to use smaller models, you can even focus on a purpose-driven, right, and computing rather use a large scale and a data center to run everything. But again, we look at the changes, we see the future, and has to be a purpose-driven AI.
We'll come to that later. Thank you for a, 3-4 minute overview of the last, I think it was like 50 years, right? 90s, 70s, 80s. Industry 4.0 you mentioned, yeah, I was actually part of the introduction of that. I was representing, I believe, Softing at that time, OPCUA at the Smart Factory, as it was called, at the Hanover Messe in Hanover in Germany, not the Hanover where first time the term in artificial intelligence, was coined. You also talk about in the 2022 paper, you talk about the 5C architecture. That is something I wasn't aware. I think I saw a picture somewhere, but maybe you can share with us what that 5C architecture was about, or maybe still is about.
Well, that 5C architecture was first introduced 2013, was published in 2015, I believe. That was one of the, I think it's quite a good cited paper. When people start talking about industrial big data, right, Industry 4.0, industrial internet, there's a hierarchical system, and from the machine component level, machine level, all the way to the decision-making level. So we call 5C. The first C is connection. How you connect machine. Do you want to connect everything, or you connect the right things? Often we say, oh, internet connect everything. Well, I said, wait a minute. You have to understand what is a high impact to your productivity, to your criticality of your work, your production, your quality, efficiency, and downtime. You need to conduct a good assessment. Then you connect to the right things. Connect to the things that you need to understand, to monitor, find those invisible degradations. Then second level, the most of the data we collected, connected, they are not in a usable format. They may be useful, but not usable, because you need to have baseline, you need a background, you need to have some kind of a conversion. So we call conversion. So level 1, connection. Level 2, conversion. You converge to good usable data. You can do machine learning ready, right? Level 3 is called cyber. Why cyber? The reason is physical machine system, they are physically and connected to perform the task. Cyber system, I can managing the content, I can managing the potential issues using a cloud-based system. So you can say cyber's approach, you can connect to multiple machines together, create analytics in the cloud. That's what we call the cyber system, right? Then fourth level is called cognition. Whatever you do, for example, your production, your many machines, but by connecting all the machine behavior, you can simulate which machine's performance is weaker, is poor. Then you can focus on those less performing machines, right? So, but I can show you the potential risk early. I can make invisible things visible. Eventually, level 4 is a cognition, to see something you cannot see. Eventually, last level is configuration. You take action to avoid potential issues. So you can configure the system. For example, I can conduct maintenance early before even machine degrade further, right? And you don't have to wait until scheduled maintenance or machine has alarm happen too late. So that 5C architecture was designed during the 2013 and 14 timeframe, and we published 2015. That's where, because doing our work with a lot of industries, we realized we need to create a structure, architecture to perform our development work.
Yeah, I recall that we've been working with similar architectures also from the bottom connectivity, which is where I was actually working in at the time, industrial communication, Profinet, Profibus, OpenCUA, every part of the world having their own system, right? Would you say that your 5C architecture still applies today? Has it been extended, or is it to be extended, or is it just fine as it is even for today as well?
I think 5C architecture, to me, we are using in our center, right? So that's a basic systematic thinking, I will call. The reason we call industrial AI is a systematic approach, because AI is not about try and error. We often use AI called ABC: algorithms, big data, and computing. I call the AI's 3 elements: algorithm, big data, computing, ABC. But in industrial AI, we focus on domain, domain. In the domain systems, right? Then you really want to understand the purpose, what you're trying to do: improve the quality, efficiency, reduce the cost, and reduce the emission. So those are the purpose. So that's what 5C thinking is, really from whatever you want, the problem level connectivity, all the way to purpose level configuration. That's a 5C level, right? It's systematic thinking. I don't think it's a code, whether it's a right thing or wrong thing. It's just a good thinking, I would say. Just a good thinking, right? So there are many good thinkings. Yeah.
I can't go into all of the details. 2 things that I read. So number 1, I come back to that later, machine learning. Machine learning, and you say machine learning has been in the past perceived as black art. I recall that as well. You say the performance of machine learning algorithms highly dependent on developers' experience and preferences. I recall exactly, 10 years ago, you were completely dependent on the person, which was kind of a professional. But sometimes you thought it was like a chemist, doing, he or she was turning knobs left and right, and sometimes it didn't, and sometimes it worked. And the only person who knew how that came about, and maybe even the person was not certain how it came about, was that person which maybe called themselves like data scientists later on, right?
Yeah, well, you're right, Peter, because if we look at the machine learning, right, the history, even early days from 1950, but the natural language processing, eventually machine learning came 1970s and 1980s, more neural network, right? So eventually evolving, continuously evolving, deep learning. So machine learning is a fundamental way of taking the data computationally to analyze likelihood. Eventually you can predict, right, and even to do root causes. But the approach normally we're taking, which to try and error, is true, because in US we started a called data challenge, we call Prognostic and Health Management (PHM) Society, 2006, 2008. The society launched a data challenge project, which means we give a data set to people, let people to use data, real data, and to compete, right? So the first year was a NASA jet engine data, 2,260 engines. Of course, our team got number one. So our student
Oh, there you go.
recruited by GE right away. But again, so that's a start. But before that, we also try many different things. So that's how we say it. When you give a one data sets, for example, Bayesian data sets, I developed a very comprehensive Bayesian data set 2003, 2005, 2 years. Now we donate to NASA 2007. That's a very well-known data set. It's been in the industry today. People using academic research, over 80,000 downloads. But sometimes you give the same data set to two researchers. You ask them to use the same tools and often there are two different results. All right. Then you say, hey, why? Oh, because I select different features. Ah, that's why. Because feature selection is a domain experience driven, and so you do try and error, and you select different features. So I often use analogy like our cooking. I give you two fish to two chefs, same kitchen, two different tastes. Everyone have a different philosophy of cooking fish, right?
Two different cooks, yeah, right.
Exactly. That's the exact same problem happen to machine learning.
Right.
But in industry, we cannot do that. For example, if a bearing has a crack, it's a crack. Okay? You cannot say, oh, I said maybe crack. Another guy said, oh, maybe lubrication problem. There's a crack, it's a crack. It's a, engineering is evidence-based approach, not just experience-based learning. So we need to have a systematic way to prove your method, your techniques is sustainable, is correct, right? And also other people can repeat your success. As an engineer, if you and I succeeded, nobody else can succeed. I don't think that's a system engineering.
Exactly. We have to be able
Okay?
to reproduce, right?
Exactly.
But what is very important is that I recall, yeah, and at that time as well, for me, we were doing machine learning. That was it, nothing else but machine learning. Now, since a year or two, we come to that later when we talk about today and the future, maybe then. In the future, maybe again, we're going to combine. But today it is, of course, for a year or two, you say, since ChatGPT, we talk about large language foundation models, but we come to that in a moment. We haven't talked, but that's going to be my question later on to you. Maybe you're still doing nevertheless machine learning. So let's see. And then the next paper that I then looked at, you talked about a couple of practical issues. It's just one very tiny little thing out of the huge paper. But I'm just interested in if those still apply or what has changed since then. I think that's from June 2020. So that's about 5 years ago. And you talk about specifically the non-availability of standardized data, the non-availability of failure data, the non-availability of good quality data. And then you also talk about the dynamic application context. So do these hold true still today, 5 years later, or have they maybe structurally changed? Has one or the other come to it?
Well, in some industry has been improved quite a bit in semiconductor industry, but in a lot of manufacturing industry, people still not quite sure how to deploy AI in the real world, right? So typically, when we talk about early years, that we did a lot of try and error system, like many others people did. So eventually, we said, okay, the ABC, the big data, really not about big, The B really means I call 3B. First, the broken data. Second, the data lack of background. The third, the data have a very vague or unclear baseline. I call 3B. If you have a data have broken, the very poor background and no baseline, the usability of data is very poor. Okay. So, but once people learn that, oh, I should improve my data preparation process. And there are many vendors, companies we work with, they start learning how to prepare better data for machine learning today. But that was like for the last 5-10 years, they have learned big deal, right? But of course, there are many companies that still wonder, oh, I have lots of data, I can do machine learning. It's not true. Many data are different forms. Some are machine readable, some human readable. But many machines have a 3B problem, broken background baseline missing. So therefore, they are maybe Excel sheet ready, but they are not machine learning ready. So some are standard issue about format, but most of them, they are not related to standard. They're really about the quality of, right? So that still remain. So we need to have a continuous improvement approach, teaching people, understanding how to collect the data in the right way, so you can use it for machine learning much easier.
Yeah, sure. Those companies, starting at a later stage can use what those that were before them have already learned, or what you as a researcher have learned and shared with the community. Now, as I say, it's a huge paper. I'm going to make that link available for those who are interested. So I'm just going to jump straight to two conclusions that you put in there. One is that you say industrial AI would not only aid in anticipating problems before they could occur, reduce unplanned downtime, but also enable every equipment to perform at its optimum level, safely, security. That's number one. And the second one is about autonomy. It says machines have autonomy to negotiate with each other, to reconfigure themselves for flexible production of multiple types of products with constantly high quality and low cost. Same question here. Do both of them still hold? I do recall from my own experience both one and number two, but do they still hold true today?
Some application, yes. Some has been changed quite a bit. For example, if you look at the advanced semiconductor fab process, 7 nano, 5, 4, 3, 2, those processes are heavily data-centric system. And very few people work in the fab. Majority work inside the data room in the fab. So by doing that, you will see there are lots of machinery. They're managed by people, right? They're highly automated, yes. But the invisible process is called the recipes, right? So normally I use a 4-quadrant to categorize what we deploy AI. We have like an x-axis is visible, invisible. The y-axis is a solve and avoid. 4 quadrants. Typically from visible space, you solve a problem. But problems, we need to understand the invisible relationship, why the product or process, the yield is not good. That normally you do offline analysis, metrology, too late. So we actually in the process data, we could find a relationship which caused those yield quality issue. Eventually you take action, configure, and to avoid. But for some high speed production, right? For example, high throughput production, SMT line, and even automotive production, and those you can produce over 60 vehicles per hour. Those are continuous flow. So we need to have a self configuration to compensate a degrade condition. For example, and the assembly line have some degradation of robots. Instead, you can have a configuration. How can you slow the speed down, or you can have other robot to perform some additional work to compensate. In the meantime, you can have a grace period to perform the maintenance. So you don't want to trigger alarm suddenly, right? So you have a grace period, then you have a continuous configuration until you perform the maintenance. But that still maintain the good quality. That window is what we're talking about. It's not forever. How to keep that allowable productivity window. We call the maintenance opportunity window. We call that term. Maintenance opportunity window, MOW.
You talk about the SMT line is one example. That brings me to the ASML. You came to Europe, but before we talk about ASML, you came, not sure which of both of them was first. You came to Europe only a couple of weeks ago. You spoke at a Davos roundtable on shaping the future for next generation AI, Innovation Hub, Data Factory, and AI University. Maybe let's stay with this one first. Can you share with us the major learnings that you recall coming out of that roundtable?
Yeah, that roundtable mainly talking about how we develop AI talents, right? And we talk about, because AI we call it 3T: technologies, tools, and talents. AI technology continue evolving, but we need to have a good repository of tools. Then we need a good systematic approach teaching people skill sets, right? For 3T: technology, tool, talents. So therefore, the question I remember was, people say, "Oh, how do you train AI expert?" And I was joking. I said, "Well, actually, experts are not that critical. AI winners are much critical." So you want to create AI talents who can really produce and productivity and create business value, right? And not just only understand AI. So the winner is more important than expert. The reason is, in industrial domain AI, we're talking about purpose. We're talking about bottom line. We're not talking about the fanciness or some kind of excitement only. But we need to create that kind of career growth, so young people or new generation, they can say, wow, there's so many opportunities, so much challenges in the factory. I like to take that challenges and to prove the future of my career, right? So that's where we are lacking today in a lot of manufacturing industries. And younger generations, oh, I have more choices, I have more opportunity in other sectors. But no, if we continue doing that, now how can you make manufacturing better?
Or it can only be lights out in the end if we don't have the people, right?
Exactly. So we have to make the manufacturing very exciting. It's a noble profession. It's an exciting opportunity. That's what I was trying to talking about, how to make AI more exciting for young people in manufacturing. Yeah.
You are at the very center of education, and I want to ask you at the end to tell us a little bit more about your environment with the students and research. But one question here then, assuming that in Davos you had a global interested public, did you talk about, United States, the president, Stargate, it's called, Sam Altman, two other companies, Oracle, and the other one, the Japanese company, forget the name,
SoftBank.
500 billion. Europe, you were in Europe just last week. They say, okay, we can also do 200 billion. Did you talk about like the global situation? It's almost like edge and cloud. Did you discuss that there is a certain concentration in certain countries, cities, which you maybe then discussed that is okay, or was it not discussed?
Well, I think there were lots of discussions. I think sometimes even flooded, right? People talk about AI almost everything, and for the last 2 years, Davos. And one big thing is, if you look at called the traditional last 2 years thinking, right? So, oh, we have ABC, algorithm, big data computing, then D, data centers, then E, electricity, called ABCDE, right? That's called AI infrastructure thinking. Everyone think, oh, if I invest more data center, more GPUs, 100,000, 1 million GPU, more money, I build bigger AI infrastructure, I will be an AI winner. But that's what most people are talking about. That's what Wall Street talking about. That's what investment talking about. That's Stargate talking about, right? But we have to rethink. We need to start thinking about the AI domain winners. In medical domain, there's so many different broken data, but we do have a lot of imaging data. That's where most winners are actually, right? So you need to dedicate the data center, even smaller data center, and small just for MRI and X-ray and ultrasound, all the images. So you have AI doctor and just to help you screening and performing analysis, even then give to doctor to final or even recommended decisions later. But that process is very important, right? So we have a material discovery. Computationally, we can find many, many different unknown materials from the current knowledge, and we can computationally prove some of a feasibilities and make the material discovery to deployment cycle from 15 years to 5 years, right? And that is a great innovation for our society. So we talk about a lot of things. Eventually, it's not just the AI infrastructure important, but AI platform. AI platform means you're open source. Open source, then people can take the open source, continuously developing new value added applications. That's what it is, right? And then eventually agent will become a closer to individuals in the mobile system, right? But that's a word from infrastructure to platform to agent. That's going to be the very critical transformation for next 5 years.
Right. Talking DeepSeek as related to OpenAI, right? For example, when talking open source. So you also went second spot here in Europe. You were invited to do a seminar, I understand, to ASML. ASML, the Dutch chip machine manufacturer close to Eindhoven, not too far away from where I was born, actually. Interestingly, I saw a picture in the kind of press release that you or they did, I don't know. I assume it was taken on site, and I did recognize, and I think it's okay to share, as you were sharing the picture, I recognized Jacek Kustra, right? Was he the person maybe even invited you, because he was on our show only a couple of months ago?
Oh, I see. Yeah, that was a good visit, though, by the way. Thank you. Yeah.
A small world, right? There you go. Not sure if it was a like paid for non-disclosure, or can you just give a couple of words in general how you would approach I think that's what you mentioned before, zero downtime semiconductor manufacturing by means of industrial AI?
I had the early engagement during the previous event, so we connect the SML. So if they invited me, they asked me to give a seminar, of course. And so I give a seminar. The topic is how to achieve zero downtime, right? But that's what a lot of things we have done for the last 20 years. So of course, a lot of discussions, NDA, we cannot talk about. But the important thing is zero downtime is a seminar, is an open number. So basically, that's what we believe in most of equipment in semiconductor advanced fab. And you take an EUV, it's a critical machine. They're running 24 hours, right? Cannot stop. So how do you predict potential issue, make zero downtime? That's what the many techniques and methods and thinkings need to integrate it. So that was most of my talk from my previous experience we learned and we have done and how to share that. That's what was about. Yeah.
Interestingly, I didn't even think about it before, because two of their main technology providers, which in this case are two German companies, so Trumpf, who provides the laser, and then Zeiss, who provide the lenses. And I was actually involved at my very, very early stage in, also, as far as I can talk at the most general level, predictive maintenance with regards to exactly these lenses. Again, what a small world. Now, in general, before we then move to the future, where are we standing with industrial AI? Where have we moved from the original machine learning? We talked about that, which was at the core of the original definition. Are you still using it? Is the world of LinkedIn and many things around it, conferences, only that part of the world dealing with and talking about foundational models and large language models? And at the bottom, are you still doing machine learning? Is that still making artificial intelligence work?
When I look into the future for industrial AI for the last few years, because we work with a lot of industries, and eventually when I moved to Maryland, and we work a much larger, a different type of industrial system, more complex. So we start using a term called non-traditional machine learning. So many people ask me, what's the traditional machine learning? Traditional machine learning is what you can learn from textbook. All the machine learning you can learn from tutorial and free courses in the textbook. Non-traditional machine learning is what we learn from by working with industry. For example, when you have a 10,000 jet engines, you have a 30,000 wind turbines. When you have a millions EV connect on the road, when you have a smart grid, right? When you have all the semiconductor machine in the fabs, all connected. The machine learning what you use is very different. The reason is different that you don't need all the data, right? You need to understand there's a criticality of those features, cost of yield, cost of downtime. So we're using a different type of machine learning. For example, I can give a few names. One area called stream of X, like production is flow. During the flow process, all the inspection, all the data, they're connected. You take a river of data, stream of quality. The quality like a river flow, continuously build up the final products. But all the correlation in each process, they are correlated actually, right? But how to develop a stream of X based machine learning? You can predict next. You can also go back to the root causes. You also can compare between different cycle. So that's called the dynamic machine learning system. And that will give a lot of powerful analytics to semiconductor industry, which we are doing right now. It can help a lot of a semiconductor process yield prediction, right? The same thing we have like we call the topological graph based machine learning. So rather, because when your data set is too large, it's very hard for you to use traditional machine learning without knowing the background baseline and the relationships, the invisible labels. So we start using those. And so normally we take 800,000 data set from one of the semiconductor companies, but we reduce to less than 20%. Then those data set that become very useful, not just useful, to create topological graph analytics, right? So those machine learning techniques is focused on a purpose, not focused on a process. Of course, the future, we have a transfer machine learning and how to take a number of a parameter from a one cluster of machine and another cluster of machine. We integrate together by using a different type of a working conditions to integrate to a very knowledgeable domain in machine learning parameter systems, right? That's what we do, transfer learning for machine tools. We did a lot of work for EV vehicles. You can predict the potential issues. But again, those are the area we're doing right now, dealing with a large, highly complex, connect industrial systems. That's what we're doing today.
Very good. Talking and moving into a bit more even what it is that you do, I assume, as a professor and as a director of the Center for Industrial Artificial Intelligence. By the way, I learned machine learning about 10 years ago from your colleague, Professor Andrew Wang, which I assume you probably know. But please, you tell us a little bit about your center at the University of Maryland. What is your mission? What is the kind of research that you do? Why should potential members and maybe also students, why should they be interested? Why should they consider joining your IAI center?
As I said, industrial AI is a systematic approach. So we develop research and education programs to nurture a new breed of engineers in using AI for our industrial systems. So typically what we do are three levels. One is a data level. So we create a data foundry as a repository of a different type of industrial data systems. We have a semiconductor data sets, we have the wind turbine data sets, we have jet engine aerospace data sets, semiconductor data sets, batteries, and all kinds, right? So by having those data sets, we use the data set to train people, even to develop new algorithms. So called data foundry, so data level. And then we also have called the tool repository. So we develop different tools like traditional machine learning plus non-traditional machine learning. We create a tool library. So when industry member comes in, they don't have to learn everything. They can use most of it well mature, well established, well demonstrated tools quickly. So typically our goal is trying to train engineer to deploy AI in one day. And you and other people may say, oh, you're laughing or think impossible. Well, that's what our target is. We want to make AI happen in one day, right? And most industry people, how do I do that? Well, that's how we teach you people. We have a student actually sent from Japan, from Komatsu, Japan, in our campus for 5 years, a PhD. So in 2023, we had a data challenge in Japan, PHM, using a Japan NASA data, space shuttle data. He did in 3 days and got number one competition in 3 days, one person.
Very good.
So student is for industrial learn, they can finish the project that they don't even know before in 3 days. And we are confident we can make in the future, right? Good engineer talents can solve problem in one day. But the third level is very important, right? It's the future, how we take the industrial large knowledge model. Because the last few years, most people heard about term LLM, large language model. But we are engineers. Engineers using knowledge to design products, not just language. So language model is text, documents, images, video, but industrial knowledge model is based on sensors, based on design features, based on models. So those doesn't have to be large in terms of volume, but has to be large in terms of value. So we create industrial large knowledge model platform, allow us to use a different type of technique. For example, we take a retrieval augmented generation, RAG, to train the system using Llama 2, Llama 3, but we generate, for example, bearing, machine tools, right? Batteries, generate. So eventually we can quickly develop that GAI-based industrial machine learning. But that's what people want to deploy, right? So LLM, many people they talk about is good, a topic to talk about. But to land, you need domain-driven purpose, right? That's what we're doing today. So 3 level, data foundry is one. We're creating a lot of data sets. Number 2, tool level. We generate a lot of tool repository so industry can use it. Number 3, the future. How we integrate those domain knowledge from different expert documents, sensors to create a new type of a large model that eventually to create a more useful a machine learning system for the industry.
Yes, I've heard about the term industrial grade, which sounds a bit like maybe incorporating exactly the elements that you refer to as well. Now, let's close with the future, like a very general, open-ended kind of questions. How is industrial AI going to develop? What do you see technologically? Who will develop it? You, but who else? Who is going to use it? I felt in between the lines, many of your answers, like learning things in 3 days, I felt this is typically also, in addition to the engineer, the domain expert. Where is it going to be? I already referred to it. You were in Europe. You are based in the US. How about China? You referred to DeepSeek. What other countries maybe in the world? And what impact is all of this going to have on our society?
Well, AI is nothing new, right? Since 1955, 56, and machine learning is continuously evolving, and new technology continues developing. I think that fundamentally, we need to focus on the not just the new, but also legacy systems. So I keep saying the legacy system, sometimes we overuse the term, like for example, smart grid. But our grid is really not smart, let's be honest. Because smart city, is your city smart? Many cities that are not smart at all. And we have a smart machine. Are they really smart? So eventually we have to rethink the legacy system we have. We have a lot of issues every day in different type of sectors, every day, repeating, right? Accident, incident, all kinds of natures. But we are not able to address those problems. So that's why the challenge for us is not just chasing something new, but also, hey, go back to those legacy systems. Why are manufacturing still ad hoc, still alarm driven? Right? We have a fancy technology, we have all the new technology, but our machine still alarm triggered and DOM driven. So we have not really make that become more worry-free yet. So we have to make industrial system worry-free, but that's where the future challenges are, right? So for the future, I'm not just talking about AI future. I'm talking about how to make our industrial system smarter, safer, and worry-free, more resilient. That's what we're talking about. So I want to focus on and develop tools more systematically can help engineers and help our future leaders able to deploy them. I want to create data set to use training, help people have a practice-oriented machine learning, not just a principle-based machine learning. Only understand the principle, right? We want to create an environment that allow people have a confidence they can solve all kinds of problems. Not just, I'm a mechanical engineer, I only know mechanical system. No, you can solve a material problem. You can solve healthcare problems. Because in data world, there are lots of new knowledge skill set needed, not just back to traditional domain world. So we want to make a data-centric thinking, right, to allow engineers can use both domain-driven plus data-based driven, data-centric driven skill sets. I see that's the future.
Thank you very much, Jay. In looking into the future, you propose us to go back to the past. You gave us an overview of the last 50, or maybe it was almost 70 years that actually the term artificial intelligence was first coined in Hanover, but then the Dartmouth Hanover, not the German Hanover. You tell us to go back and look at our legacy systems, which we have been calling smart, like we are calling our city smart, but they are not really. And you tell us to make them actually smarter, make them safer, and make them more resilient. Thank you very much, Jay. It was really a great honor to have you on our show, to get your view, to get your perspective. Thank you very much. And next time you're again in Europe, close, let us know. Maybe we can meet up sometime.
Sure. Thank you for the opportunity.
Thank you, Jay. Bye-bye.
Bye-bye.